right? So this is ME. Wk04. This is week 8. And today we are still going to do our agenda for today is going to still be instantaneous center. Okay. And yesterday I was very bothered by something. Okay, I was bothered by something. A student asked me a really good question. Eugene, can you pick something from the previous example to do instantaneous center? And I picked one. And unfortunately, the example was pretty crappy. Am I right? It will not work. So I decided, hey, need to show them something that works. If you show them something that don't work, what's the point of learning this? Okay. So I decided to pick one example from week 7. Okay, on a Monday. So the example I like to pick is this example over here. Okay. So I'm going to copy. So if you go to week 7, you will see this example. Okay. So what I'm going to do, you remember this example, yes? Yes or no? Yes. Okay. So I'm going to see whether is it possible to work on this example. Okay. To work on this example using instantaneous center. Okay. So the thing about instantaneous center, as you all know, okay, the thing about instantaneous center, the important part is this. Must know the orientation and magnitude of the velocity of the what type of velocity? Linear velocity vector. This is the important thing. Okay. Without knowing the linear velocity orientation and vectors, we cannot use the what? Instantaneous center. Are we clear? So this is a clear. So this technique, I'm going to highlight to you the operating limits. What are the limits of applying this technique? Okay, more important. So before I go there, I'm going to look into our handout. Come on, Eugene. Okay, we're going to look into our handout, and the handout was on when? Was on week 7, and I believe we were doing this on Monday. Okay. Is it Monday? No, Tuesday, Eugene. Okay, we were doing it on Tuesday. Okay, so I want you to see the amount of work that we have to go through. Okay, so it's a pretty long question. Now, will instantaneous center help? Okay, so now what we want to determine, coming back to this problem, we would like to determine VC, right? We'd like to determine VC. To get VC, we have to determine our rigid body. And we remember that is our member CE and our member AB, members AB. Okay. So from here, we can write out the expression that VC is equal to VD plus by omega CD cross R C from point D. Okay. Unfortunately, we have unknowns. So the unknown that we have is we don't know what is our VD and we don't know what is our omega CD. Okay. So now we want to determine, okay, before we can go there, we want to determine our omega AB. Okay, we want to determine omega AD, right? Because we need VD, okay? So omega AB, so what formula are we going to use? Okay, the formula, so we need to determine omega AB. Okay, so the formula that we want to use to get VD, okay, so VD is equal to VA plus omega CD, oh no, omega AB cross R D from point A. Okay, so we want to find, we have to use this equation over here. Okay, so we know VA is known, so VA is equal to what? Is equal to minus 4J. Okay, but we don't know, unknown is our omega AB. Okay, so now what we are trying to do is I'm going to use the instantaneous center to determine omega AB. Okay, I'm going to use the instantaneous center. So I'm going to, you know, this instantaneous center stuff is very graphical, yes or no, right? So I'm going to have the diagram here to help me out. Okay, I will string it. Okay, and I will apply the instantaneous center method. Okay, so what do we know? We are aware that at point A, we have a velocity vector coming down, vertically coming down, and this is coming down at 4 meters per second. So VA is equal to minus 4J. We also know that our VB, okay, our VB is heading towards this direction. VB. So I'm going to use green color to construct the instantaneous center. Okay, so I'm going to choose green color. And we're going to construct instantaneous center. You have one point from here to here, right? And then you have another point from here to here. So we just identify our instantaneous center number 1. Yes or no? Nothing new. Yes? Okay. So now we are going to write, we are going to write this out. Okay. So we know we know that VA will be equal to omega A stroke IC1, right? Multiply by the radius or multiply by the distance A IC1. Okay, knowing that over here is point A and over here is point what? Point B, right? So from here, once we know that VA is equal to what? So for this case, we are just only bothered about what? Magnitude. We don't care about vectors now. Okay, but we know that this will be rotating in what direction? So this is your omega AB. Okay. So VA is equal to 4. Omega AIC is what we want to identify. AIC1, so this is what? 4/5. let me write square bracket. 4/5 multiplied by 0.55. So omega A IC1 is equal to 4 divided by 4/5 multiplied by 0.55, 0.44. So we identify this as 4 divided by 0.44, 9.0991 radians per second, and is going in a clockwise direction. So we know that omega A IC1 is equal to omega B IC1, and this is equal to omega AB. So this will be equal to 9.091 radians per second in a clockwise orientation. Okay. So if you were to look at the working, we have worked less than a quarter page. Yes or no? Right? If we look at the previous technique, can you see the level of math to get 9.091? Can you see that? Yes or no? Right? Can you see? Can you all see 9.091? Yes or no? If you can see my cursor, 9.091 is over here. Can you see how much work we have to do? Right? We are humans with path of least work. Yes or no? Okay. You decide what you want to use. Okay. Now the next thing is this. Now we know what is our what? What is our omega IC1, right? Then comes to this problem now. Now everything is not like honeymoon, okay? Sometimes you have to go through a bit of hardship. Are we clear? Okay, that is anything that you do in life, and marriage is the same. Okay. Right. So now the thing is this. Can we apply the same technique to find VD? Okay. Now VD, so we now want to find what? We have to find the IC for points C and point D. Right? I show you one way that we can use AB, right? AB could work because we know what? We know the orientation of the what? Velocity vectors. Yes or no? All right. Point D, do we know? Don't know yet. So for this case, we cannot apply instantaneous center yet. I repeat again, up to now where I am now, we cannot apply what? Instantaneous center. Why? Because we don't know what? VD. So very easily we can find VD. So VD, so using rigid body AB, okay, we can form that VD is equal to VA plus by omega AB cross R D from point A. Okay, so we formed this equation before. So this will be equal to minus 4J plus by minus omega AB is minus 9.091. 9.091 K. Sorry, I'm getting too excited. Okay. Cross R D from point A. So minus, so square bracket minus 4/5 multiplied by 0.3 I, and then positive 3/5 multiplied by 0.3j. And then close bracket. So this will be equal to minus 4j, right? So will be equal to k cross I is positive, negative, negative, positive. So plus 9.091. That's by 4/5. That's by 0.3. It's equal to 2.182. Okay, plus by 2.182j. K cross j is negative. I have a negative, so it become positive. So 9.091 times by 3/5 times by 0.3 is equal to 1.636. So this will be equal to 1.636 I minus 4 times by 2.182. Times, seriously, Eugene? Minus 1.818j. Okay. So we now know our